Hey folks, I'm Mr. Hartzler, and I want to talk to you in this video about piecewise defined functions. And before we do, I'm going to share my screen with you, but also, just so you know, if I'm looking around, I'm looking at some of my notes, textbook, and my drawing tablet a little bit. Sometimes I look at that to help me figure out where I'm drawing, and I'll be looking at different parts of the screen because that's where all of this shows up. If you have any questions, make sure you leave those down in the comments too as we go. And if you're one of my students, make sure you ask me for help through email or, well, through email, not through the comments. But if you have just a general thing, put that on here too. All right, let me share my screen with you. Here we go. All right, piecewise defined functions. Here we go. I'm going to drag myself over here. And let's go to the next one. Ooh, drag down too. So these are our goals here. This is a target. I can graph and interpret piecewise defined functions. Let's go and do that. First one. Janet has a summer job as a lifeguard. She makes $8 an hour for up to 40 hours each week. If she works more than 40, she makes time and a half, or 1.5 times her hourly pay. And that's for every hour over 40. So if she works 41 hours, she doesn't get 41 hours at the 1.5 times her pay rate. She gets 40 hours at the normal one, and then the 1 hour at time and a half. So just so we're clear on that. How could you make a graph and write a function that shows Janet's weekly earnings based on the number of hours she's worked? Well, let's dive into that. So I'm going to first make sure I go up to the top of my screen and hit annotate because I don't want that to happen again. Awesome. I think that's ready. So first 40 hours. So let's say she works 1 hour. She ticks up just a little bit, right? She starts making some money. And let's say it goes up about like that. Okay, so whatever the scale has to be here, you know, there's 8 and there's 1 hour, whatever that scale happens to be. My picture is not going to be so great. And at 40 hours, I'll just go up a little bit more. All right, there. 40 hours a week, she is up to $320 because that's what 8 times 40 is. Okay, 8 times 40 is going to give me the $320. Sorry, my handwriting might be pretty sketchy on here, but first time using the drawing tablet all summer. So, or since summer started. I didn't do any videos over the summer break, which was kind of nice for me. Anyway, so after that, she starts making more money, right? More money, more problems, but more money is also kind of nice sometimes. So every hour after that, she makes $12 an hour. So that's a steeper line, right? She's making X. That line doesn't look steeper. I'm going to be dramatic about it. Boom. Dramaticer. Compared to this other line, which wasn't blue, it was green, which would be down here. Again, the green line doesn't exist, those green dashed parts, but I'm just showing as an example, it is steeper for the red line. All right, so let us write down what this formula would be, because that's the next part, right? We have to write a function. So that's going to be f of x is our function. Oh, lights just kicked out. Apparently I'm not walking around my classroom enough, but got desk lamps, we're cool. All right, first part, the green part here. Let me change the color of my marker even. So she makes $8 an hour for the number of hours she works. That's X. But that's not what she makes for this whole thing, right? The piecewise, or a function that's broken up into pieces. The piece that this one works for, the domain that this function is valid for, is only between 0 hours and 40. So X has to be between 0 and 40. It can also be equal to. So X is greater than or equal to the 0, and X is less than or equal to 40. Because if she works 0 hours, she just gets $0, right? But that's 0 hours times the $8. If she works 40, it's 40 times the $8. So that's going to be an equals to, and we would also have that make sure in green, that's a solid dot. She can be there. I like to think about equals to and solid dots because I can sit on that location. It's like a filled in chair. The open dots, you can't sit there. You'd fall right through that chair, right? You can't be equal to that. So the next part is red. And this one does get just a smidge more complicated, right? Because she made $8 an hour times the 40 hours a week. But she made more also, right? She made $12 an hour times however many hours over 40. So number of hours minus the initial 40 that's hanging out over here, right? You have to take that into account. Because she doesn't get $12 on top of that first $8 an hour for 40 hours. No, it'd be ridiculous. That's $20 an hour. It's just a lifeguard. I'm sorry, but I mean, most kids swim. Anyway, let's simplify this a little bit though, because that's muddy. And then we'll come over here and we'll do its domain. 8 times 40, 320. And now I'm going to distribute this 12n. So that's plus 12x and minus 12 times 40 is 480. I can combine like terms. So I have 12x minus 160. That's the part that goes into my function. So I'm going to write down here too, the domain for this, or its restriction, is going to be that x has to be greater than or equal to 40? Nah, just greater than 40. I'm actually going to erase this junk here too. If you need to see it again, go back in the video. That's why it's on YouTube. So there's that. And can I select this? And I'm going to drag it on. Oh, select mouse. It's not gonna let me do it. Anyway, that part is up here. Click, click. Sometimes this thing gives me fits. All right, anyway, this part is up here, right? So I have 8x with this restriction. I have 12x minus 160 with this restriction down here. Not too bad, right? Let's save this. Why is shift frozen? All right, so now we're on to our next problem. This is example 2, and we are going to graph this piecewise function. This can be tricky sometimes, but it's not as bad as you think. We're actually just going to look at it in each individual piece, all right, piecewise. So let's look at the first one, and where's my cursor? There it is. Let us annotate this, and we're going to be drawing. All right, so this top piece, the first function is 4x plus 11, but that's only on this restriction from -10 to -2. So I'm actually going to plug those things in. So let me drag my face out of the way a little bit. So 4x, so I'm going to plug in my bottom restraint, which is a -10 plus 11, and that's going to get me -40 plus 11. Oh, that's a negative number. That's real negative, right? That's -29. Very negative number. So I plugged in -10. I got out a -29. So let's do the other side of that. The other side is going to be 4, but I'm plugging in a -2. And then I'm adding 11. So that's a -8 plus 11. Not as bad, right? That's just +3, in fact. Plugged in a 2 and got out a 3. So this whole grid I'm going to do by 2. So that's a -2, -4. This one's a +2. This one's a +2, +4, and so on. You get the idea, right? So I plugged in a -2 and I got out a +3. So that's right here. But is that going to be an open dot or closed dot? What is based on this inequality? That's strictly x less than, no equal to sign. So it's going to be an open dot. So I'm going to make that just a little more big and obvious, open dot. And then my slope of this line is 4. So I'm actually just going to go down 4 over 1, down 4 over 1. And I think I can make straight lines with this. And boom, that was kind of cool. And then my little arrow on the end, because it keeps going in that direction forever, which is kind of cool. Now I need the next one. This one's going to be curvy. It's an x squared, so it's a parabola minus 1. So that's a parabola shifted down 1. And then I'm real curvy, right? And you can take my word for this, but it overlaps. Where's my cursor? There we go. It overlaps with this little guy. Ooh, wrong color. I need to swap out my color. Hold on. And so my first one, it's been shifted down to 1, right? That's what that's about. And the x squared means it's going to be a parabola. And again, you can take my word for it. You'll have to plug in some numbers to do some guessing and checking up in there. This one is a solid dot. You know why? Do you? Well, or equal to line right there. Same thing on the other side. It's equal to on that side. So let's plug in a 2. 2 squared is 4 minus 1. Well, that tells me I'm up at 3. So if I plugged in a 2, I got out of 3. That's how I know this part too. Oh, that's not curvy enough. Use that bottom line there. That bottom line's curvy. All right. And again, I am equal to on both of these. So there are solid dots on both sides. Please make those big and obvious that they're filled in. Let's look at the next one and let's do green. So this one with these two restrictions, right? I should circle, not do lines. So x plus 1, plugging in that 2 plus 1 gets me a 3. So 2 was my in, 3 was my out. So over here at 2, I'm up at 3, but that's a big open dot because it's not equal to. Then I'm going to plug in my upper restriction. So that's going to be a 10 plus 1 gets me 11. Again, plugged in a 10 and got out the 11. 4, 6, 8, 10 is over here. And I got out 11, 6, 8, 10, 11. Right here. Good. And the slope is 1 over 1. So I'm just going to come down 1 over 1, down 1 over 1. Then I'm going to go get my straight line tool because that is sweet. Now that I have found that right to there. And this one does, in fact, get bigger than 10. So I'm actually going to do that line off still that direction, make my arrow this way. And that's pretty cool, right? So now we've done our graph based on each of those things. And you notice what I did a couple of times, right? I plugged, even for the parabola, though I didn't quite explicitly say that. I took the lower number, plugged it in, took the upper number, plugged it in. And that's how I got my 2 points and connected my line or my curve in the middle. So let's go on and let's do our next one. So now I have a graph. I need to change this so that it is actually into a function. So first thing I need to do is write down that there's going to be, where's my tool? There it is. F(x) equals, and then I do a S and a 2 to that little squiggly bracket. Let's do the blue one. It's this part down here. So it's a graph. It's a straight line. I cross right here at -4. Remember, lines look like, I'm going to just write over here, mx plus b format for the most part. So our y-intercept is b. So I cross at -4. I know I'm going to have an x there. What's my slope of that line? Okay, so they're doing a spacing of each grid space is 2 by 2. So I go, let's see, up 2, 3 over 1. I go up 3 over 1. I'm going to rewrite that, right, because that's just a 3x minus 4. Then I have to talk about what it's bounded between. What's its restriction? What's its domain? And I'm locked up between -2 and +1. But now I have to figure out, is it less than or equal to, greater than, whatever. So it's always going to be x greater than the small number and x less than the big number. But now, is it equal to or not? Well, it's equal to the small number because it's a solid dot down there. So little equal to bar. I'm going to rewrite that for you because it's all muddy. That's a -2 is less than or equal to. I keep this not equal to the 1 because it's an open dot there, big open dot. All right, so let's switch it up. Let's go to red. And that one, let's see. Let's do the slope first. And I can subtract the y values and subtract the x values and divide them. So 8 minus 4 over 5 minus 1 gets me 4 over 4, which is a slope of 1. Sweet. So it's going to be 1x, and then what's my y-intercept? Well, if it's 1 to 1, right, and I'm over here at 1, 4, I go down 1 over 1 more. Sweet. So that's going to be a +3. And what two things am I between, right? Which x values am I allowed to have? Well, right here, this is at 1. And up here, this is at 5. And you'll notice both are solid dots. So we are equal to's with our x in the middle. Nice and cute. And the last one is green. And green is a flat line, which is just going to be a number. And it's whatever this number is here. So it's just 8. Well, and which x values does that happen? Well, it's just from 5 to 8. 5 to 8. Now, greater than, equal to, less than, what is happening here? Well, our red dot was there at 5. So it's not equal to, because I can't have a green line and a red line at the same spot. Those dots can't overlap. It's a no-go situation. So right here, the 8 I am equal to, because that is a solid green dot there. All right, so our last one is going to be to turn this absolute value function into a piecewise defined function. Not as hard as it might look, right? because this little fella is absolute value, but it's not too terribly complicated. You can shove this into Desmos and it will get you a pretty cool graph. I'm going to show you the algebra for it, okay? But all of them are treated very similarly. First thing I'm going to do is see this number in front of x. I'm going to factor it out. So this now becomes 6, absolute value of x plus, remember I pulled it out of this PR2. If I'm factoring it out, I take it out of both things. So what's 18 divided by this 6? 3, if I can draw 3. There we go. Now I've got to look at this. So x, whatever is in here, is going to come out as a positive, but x can be all kinds of crap in the middle, right? And this, if I were to graph it, is going to be to the left, 1, 2, 3. And it's an absolute value. And absolute values, if you remember from Algebra 1, look like a V. So it's actually 2 lines is what I'm going to be doing here. So the first part of that line is going to come from the positive version of it. So this one over here, this one is going to come from values less than -3, okay? Less than -3. So that one, how do I determine those things? Well, my equation for that is going to be the negative version of, instead of using absolute values, change those to parentheses. Boom, that is your equation for that. That's kind of cool. The next thing I'm going to do is figure out the positive version of it, or this, use a different color, this graph on this side. And that's actually what's going to come from the positive version of 6x plus 18, which is kind of cool too. So that I now need to determine what are all of their limits, right? What are their bounds, their domain restrictions? For the green part, it's going to be that x has to be less than or equal to -3. And for the red part, x has to be greater than or equal to -3. It's kind of cool. And then over here on the left, and I know before, so I should say this, before I had said that I can't have a green dot and a red dot in the same spot. But in this case, it's true either way. So you really just have to say, or take this with a little bit of grace, or you could even say that just one of them, we'll say this green one, we'll say that part doesn't count, even though they're both covered there, because they can't both be over the same spot, though you could pick either one to be equal to. And if you have any questions, of course, please email me. If you're not one of my students and you have a question, drop that in the comment section. If you're one of my students, remember, I don't check comments all the time, so email me your questions. And I'm excited to see you in class, and I hope you have a phenomenal rest of your day. Bye, everybody.